Okay, so this is section 2.2, and again, try to do this on your own because that's how you learn how to think mathematically, is by trying something and then seeing what you do right or wrong. So go ahead and read the Explorer, try to do problem A, part A, and then I'll come back in a second. So pause and we'll come back. Okay, so we have two different students here. We have Ben and his schedule and Kate and her schedule, and then how much they study. So if we read question A, it says find the overall average number of study hours, so study hours per credit hour. And again, if you know some things in math, it does help. So this is a rate, right? And we've talked about rates tell you what to do. Number of study hours per credit hours. So I know I'm going to divide because that's what the rate tells me to do. All right, so for Ben, what do we see? Overall study hours. So what are his overall study hours? Well, 21 hours per credit hours. So that's 12 credits. So we're going to divide. Now, again, don't multiply by 100. You're not converting it to a percent. It is a rate. So when you divide, you get 1.75, and both units stay. They don't cancel. So you get hours per credit. So what that means is he's studying 1.75 hours per every one credit that he takes. All right, let's look at Kate over here. Kate, total number of hours, study hours, is 19. So 19 hours of studying. And then per 16 credit hours. And so if I divide for Kate, I get about 1.19. So about 1.19, and that would be hours of study, so study hours per credit. So for every one credit, she studies 1.19. All right, so the rule of thumb is that you should do 2 hours for every credit hour. So for example, if you're in a 4-credit class, you should spend a minimum of 2. So that would be 8 hours a week, not coming to class, but doing the homework and so forth. So then if you're taking a summer class, that would be double time. So it would be 16 hours a week for a 4-credit class. So again, this is considered for a normal semester. All right, so you can kind of think about how you're doing. All right, go ahead and read part B and then try to figure out what they want you to do there. And I'll come back in just a second. Okay, I'm going to give you a hint here, and then I'm going to come back in a little bit. But read what it says. Again, these are rates. So it says, find the hours studied per credit hour, but on a course-to-course basis. So again, we're going to take hours studied per credit hour, but it's like for history. So how many hours did they study for history per how many credit hours was that course? All right, so let's look at history. History was the person studied for 6 hours, and history for Ben was what, a 3-credit class. So if I divide, I get 2, and that would be hours per credit hour. He's studying 2 hours for every 1 credit hour of the class, which is what you're supposed to do. So go ahead and figure all that out for Ben and all of that out for Kate. And I'll be back in a second. Okay, so again, to get the statistics, I took the 6 hours studied divided by 3 credit hours. Psychology, I took the 4 hours studied over the 3 credit hours. English, I took the 5 hours that they study divided by the 3 credit hours that the class is. And then I went ahead and did the same thing for Kate. So 6 divided by 3 for history, 6 divided by 6 for math, 4 divided by 4, and 3 divided by 3. Okay, and then here what I want is the average of these numbers. So we're going to average these numbers. All right, so add them up and divide by 4, and you should get about, 1.75 for that guy. And then if you add these up and divide by 4, you get about 1.25. All right, and so I want you to go back and look at this question up here at the beginning. And again, I'll give you a little bit of time to think about it. It says, does this result match? So when we average the kind of averages, so to speak, or average the rates per course, it says, does the results match Ben's overall average in part A? Why or why not? And then how about Kate? So if we look above, when we did the math up there, we got 1.75 for Ben. And then we got 1.25. So write down one reason, or sorry, that's not right. That's what we got down there. Up above, we got an answer of what, 1.19? Okay. So try to think and write down one reason why his matched when we averaged all of the credit hours and then averaged classes, and why hers does not when we averaged the individual classes versus the overall average. So I'm going to pause, you think about it, and then write down one reason you think that might be, and we'll come back. Okay, so why do these agree? Well, and why do these not? So what's different about Ben and Kate? Well, if you look, his classes are all the same credit hour. So if I do that all together and get the overall rate, or if I average the averages, each class is worth the same. So dividing by 4 is okay because they're each worth 3 credit hours. So every course is equal as far as how much time he should study. So it makes sense that you could do either. But if you look for Kate, here, if you look at the overall, some classes are worth more than others. So like this 6 credit math class, she should be putting in twice the studying of that than what she does for history and English, because it's a 6 credit course. So like if she studies 6 hours for history, she should study 12 hours for math. And so this is fine, but then when you average the 4, they're not, you can't average. Math is worth twice what history is. So how can you average it? Or like chemistry is 4 credit hours. It's worth more than English and history as well. So that's why they don't agree, because you can't average the averages if they're weighted differently. All right. So read the next section and I will pick up our problem number 2. Okay, so we're going to talk about a weighted mean. And a weighted mean is, the word mean means average, okay? So a weighted mean just means when you average things that some are worth more and some are worth less, and you're trying to figure out the average. You can read this example. This looks really scary, but it doesn't. It means take the frequency times how much it's weighted, add those all up, and divide by the total weights. And I will make a chart for this. So this formula looks super scary. Just know that this sigma guy just means add up all those values, and then we're going to divide. And again, I have a chart for this, which makes life way easier. All right, so let's look at number 2. Find the weighted mean of 15, and it's hard to see here, 15, 25, 100, and 250. And it says if the 15 carries 4 times the weight. So this guy carries 4 times the weight. All right, so think about how you would do that. And then, so that means it's kind of like this is worth 4 times these are each worth 1 time, and this is worth 4 times. So we'll come back, try to find the average, and then I'll show you a strategy for that. Okay, so one thing you could do is if this is worth 4 times, you could write it 4 times. And then, 25, 100, and 250. And then you could add them up and divide by, how many numbers is that? 7. But happen if there's 100 of these or 200 of these, you do not want to do that. So what I like to do is I like to consider this like a weighted, in a sense, a weighted grade. Okay, and these might not be grades or whatever, but how it's weighted and then what the value of it is, so like a weighted grade. And you always multiply these, because if something's twice as heavy, you'd multiply it. 3 times as heavy, you'd multiply it. So the weight is how many of them I have. So this is weighted 4 times. It's 4 times heavier than the other guys. I don't know why I just did that. Sorry. The rest of them are all weighted 1. Okay, so like I have one of these, and one of these. And so this has a value of 15. This has a value of 25. This has a value of 100. And this has a value of 250. And so when you do weighted grades or weighted values, you weight the value. So you just on this little chart come across and multiply. So what is that? 60, 25, 100, and 250. And notice that 60 is what you get when you repeat add 4 times, because remember, repeat addition is multiplication. And so then if I add these all up, I'm going to get sum total here. What is that? Oh, what is that? 5. There's what? 7 is that? 13. Is that 435? 250, 350. 410, I think so. And then you need to divide by the total weight. So here we have 4, 5, 6, 7. So I'm going to divide this number by 7. And when I do that, I get a weighted mean of 62.1. And notice that is the same answer if I wrote 15, 15, 15, 15 4 times and then added the other numbers in once. Notice how I would have 7 objects and my sum would be the exact same thing. So I'm just weighting this, going across, multiply, weighting, 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 add up, but then you have to divide by the total number of weights. And so the average is 62.1. All right, go ahead and read page 167. And we'll pick up there. Okay, so hopefully you read through the example on page 167. The only difference is I like to make a chart as well, but when I make my charts, I like to do weight and then grade, because that's what you're really doing here is you're weighting the grade. So weighted grades, if someone say, oh, the teacher does weighted grades. And again, remember you have to multiply, because if you weight something, it makes it heavier. Like, if I weigh 3 times someone else, you take their weight times 3. Now, the weight is, in this case, the teacher decides the weight. So 60%, I put these in decimal form. So 0.6, 0.3, and 0.10. So again, they should add up to 100% or 1 in the decimal form. But again, the teacher is saying exams are super important. They're 60% of your grade. They're more than half. Quizzes are also really important. So look at 90% of your grade is right here. Now, homework is important, but they're only giving you 10% for that, probably because it's done outside of class and there's no one proctoring it. So, you know, they might want to make sure that you learn from homework, so they want to give you some points for it, but they're not going to weight your grade heavy on that because you can get a lot of help with homework. All right, now, the grade is the average in each category. So notice this person has these grades for exams, these grades for quizzes, and their average on my math lab is 88%. So my math lab, the average I know. But these, I, as a teacher, would have to average those by hand because, you know, the computer's not, if they're not on the computer, then I'm going to have to do that by hand or on a computer program. So go ahead and find the average here and find the average here. And then try to find the weighted grade. So finish filling out this chart. Try to use it to find this person's grade in this class. So I'm going to pause and you try to do that. Okay, so let's look at the 2 categories that we have to average. These are already percents. So I'm just going to add them up, divide by 3, and get my average. Now notice if you understand kind of the Robin Hood situation, I could steal 10% from this guy and give that 10% to that guy. And I could also get the average there because the numbers are pretty nice. Quizzes are not in percent form, so you could put this as 70%, 60%, 60%, and 110% and average them, divide by 4 if you want. Or I just did total points. So I added up all the scores on the quizzes, divided by 40, multiplied by 100 to convert it to a percent. So now we're going to go back up here to our chart. So the average for the tests was 70%. The average for homework was 75. And then here we are. All right, so it told. Okay, sorry about that. I had some issues, and so I just tried to back it up. So if there's a glitch there, I apologize because this is not the easiest thing to edit. So, all right, so let's go back to that chart. Again, I love weighted grades. I like to do it that direction. So on my math lab, they might do it backwards, but I think this is way better. So I have my weight for each category, and I have my grade for each category. So I keep one of them in percents because otherwise you have to move the decimal at the end. So I like to put my weight in decimal form and my percent here. All right, so multiply across, add down, and then divide by the total number of weight, which in this case is going to be 1. So multiply across, get all these numbers, and then add down and get this, and I'll come right back. Okay, so we need a weight and a grade. So what they're saying is, hey, this is 60% of this grade is going to go towards your final grade in the class. So multiply across, 30% of this is going to go, and 10% of this. And so then you add them all up, and then you divide by the weight, which in weighted grades is always going to be 100%. So this is going to be 1. And that's what that funky formula meant. Add up all the weighted grades, like when you multiply, and then add up all the weights total and divide. And that's exactly what we did. We multiplied first all the weights by all the grades. X is the value. We added them all up, which was this answer, and we divided by our total number of weights, which was that column right there. So again, weighted grades, if you make the chart, they're not too bad.